So you're welcome back to the last part of this week 5 video, and this is where we're going to learn the application of the JavaScript fundamentals. So algorithms will help us to do that. So the power of algorithm. So an algorithm is a step-by-step approach of solving a problem, either simple or complex. One of the oldest form of algorithm is the pseudocode algorithm. Now this type of algorithm is you write the steps that you tend using to solve the problem into simple English steps or explanation. So say for example you bought an indomie. I don't know how to cook the indomie. So if you look at the instruction, you see what looks like a pseudocode algorithm. So see the first step, you see you get your indomie, you get water in a pot, you light the fire, put the pot, light to boil. So you see they tell you some few steps that will help you enjoy your first indomie. So that is like an algorithm. So it's a step by step. It's the oldest form and the most powerful. Now once you write an algorithm, a step by step in pseudocode algorithm, you can convert it to any type of algorithm. So there are different types of algorithm, but pseudocode is the simplest and has an advantage in the field of programming. So power or importance of algorithms. With algorithms, you can use basic knowledge or principles to build something complex. So I'll show you some steps of how to write pseudocode algorithm for any problem. Now note, pseudocode algorithm is written in simple English. So just as I've explained earlier, this means it can easily be converted to other types of algorithms, and the algorithms can be executed using other script languages apart from JavaScript. So in this video, you see me using JavaScript because that is a language that we are learning for the web, but the same algorithm that you develop for a problem you tend using JavaScript, you can be converted to the one that use Python, C++, Ruby, PHP, any script language, Dart, Kotlin. So there are so many of them. So algorithm is very important because it helps you to use basic knowledge to build something complex. So remember, an algorithm is a step-by-step approach. So when you have a problem, don't easily assume this problem is difficult. Try to break the problem into steps. And how do you break the problem into steps? So let's look at, we'll get to understand by the time we move to the steps in developing what? A pseudocode algorithm. So steps to write a pseudocode algorithm. So the first step is what? Understand the problem. Very important. And this may involve some form of research and study. So as you study or do your research, look for patterns. So you might read about through 2 or more references about a topic. So as you read them, look for patterns. What are the similar things that each of these reference is saying, and what is the unsimilar ones? So is those unsimilar ones, are they relevant? Can I do without them? So those are some of the questions that you should ask so that you understand the problem. So let's say you want to build, for your project, you want to build an app or something like that mimics how you transfer money to your ATM, and you've never transferred money before using ATM. So you have your Google there, you have your many search engines, so you can watch videos on how to transfer money, you can read blogs on how to transfer money, so that you get to understand how and why the ATM machine is designed to work the way it does. So only then can you move to the next step. Write out the logical steps to solve the problem in simple words English. So this step is very important. Your understanding of the problem will determine how long this logical steps will be. So if you do a good job, you won't have to repeat step one, so you won't go back to it again. But if you do a bad job, maybe because you're in a hurry, you will later find out that the steps you wrote are not even necessary or need more steps. So you have to take time to do the research. It's the core part of writing an efficient algorithm. Now after you've understood the problem and you've written the logical step, the next step is convert the logical steps into script language, for example JavaScript. Your level of knowledge of JavaScript will make this step easier. In case you have forgotten this topic or you don't know it, feel free to do research, understand the topics and apply them to the problem. So you must not learn all the topics in JavaScript, which is JavaScript is very wide, before you can start solving problems. So after you do that, the next step is to test the code and fine-tune it to handle possible errors or exceptions. So let's apply this to solve our problem. One simple problem. So remember, we just learned about variables, loops, conditional statements and all the rest. So let's use it to solve this problem. So we have this, we have algorithm. So let's solve this problem. Develop a pseudocode algorithm that does what? That gets the even and odd number that gets the even and odd number within a given number. So the problem is develop a pseudocode algorithm that gets the even and odd number within a given number. So if the given number is 5, so what are the even and odd number from 0 to 5 first, for instance, or from minus this to 5? So that is below. So the next step is, so this is the problem. So this is the problem. So now the step 1 of this is to do what? Understand the problem. So to understand this problem, you need to ask yourself, so what is an even number? What is an odd number? Well, from mathematics, you know that an even number is a number that when it is divisible, when you divide it by 2, has no remainder. So like 2 divided by 2 is 1, remainder 0. So that is an even number. Odd number, if you divide it by 2, it will remain 1. So that is an odd number, like 3 divided by 1 by 3 divided by 2 is 1, remainder 1. So 3 is an odd number. So that is all we need. So So now the next step now is, now that I've understood the problem, what are the logical steps? So the first step is even number divide by 2 without a remainder, then y odd has a remainder. So that is how simple that one can be. So the next one is the logical steps. So what is the logical step that I use to get this number? So you see from the problem statement, we need to do what? We need to get the what? The number. Then we need to generate numbers within the what? Given number. So if they give us 10, so we want to give, so it should not be greater than 10, from 0 to 10 or from 1 to 10. Then when we generate the number, then we'll filter out even, odd, and what? Even. So when we filter out, then we'll do what? So as we are filtering, we store the even and odd separately, because if you don't separate them, how will you output them as even and odd? Then you return even and odd number. So these are the possible steps. Now the next one is to convert this into JavaScript. So how do I get the number? So I'll request for it. So remember the function I will just learned now. So to get number, I'll use a function. So this entire problem will be a function, and by the function parameter, I will get that number. So how do I generate the numbers within the given number? So here I'm going to use loops. So you see loops, so I can use the for loop, the while loop, so any of them I want to use. Then how do I filter the even and odd number? So I'm going to use modulus. So now this modulus, I'm going to use it to tell which one is even. Then so I'm going to use modulus and what? If statements. Then I'm also going to, so how do I store the number? So I'll store them inside an array. So imagine as while the number, I'm generating the number, so I'll be pushing them into different arrays. So I have like 2 arrays, so even array, odd array. Then I will now return the arrays. So you see how the topics come. So from this now you're able to generate this. So the next part now is to convert. So that is the last part. So convert to scripts. So by mentioning these topics now, so if I want to use Python, if I want to use C++, if I want to use any script language, I'll use any of this. So let's call this function even, odd. So we need what? The number, so we can call that A. Then we need to generate numbers, so I'll use my for loop. So let I be equal to, so let's use from, so the program statement was develop an pseudocode algorithm that generates an even number within a given number. Okay, let's use from. So you develop a pseudocode algorithm that gets the even and odd number from 1 to a given number. So it should be from 1, because if you don't put this restriction here, that means it can be from minus infinity to the given number, which will be too long. So let's add that here. So that will be 1. Then the increment I less than the given number or equal to the given number, so that is A. So whatever that given number is, so A, so I plus plus. So you see how we are applying that now. So now I have my loop. So the loop now, I'm generating the number. So this will generate from whatever value I pass here is 10. So from 1 to 10, I need to stop. Remember this. So now the next thing is to filter. So if, so I'll use my condition. If I modulus 2 is equal to 0, so that means this will be an even number. So it is even. Then else this will be an odd number. But remember, I need to store those numbers. So I'll come here, I'll say let even be equal to an empty array, then let odd be equal to what? An empty array. Remember how we pushed to an array? So you can use splice, you can use this, but for this instance, push can do the work for us. So what value will I push? So remember, what is generating the number is I. So once this condition is met, so I want to push to even, so I'll say even dot push I. Then if it is not true, sorry about that, I have to push odd dot what? Push I. So at the end of this loop, so by the time the loop stops, it has done the filtering and storing. So then the next thing is to return. So I will exit this loop. Then I will now return. So return. Now there are two ways we return. You can return. Now if I return this as even, so that means I will only get the even part, but the odd part I will miss it out. So let's check that. So if we want to run this now, so let's say console.log. Even, odd, so let the number be 9. So if I do that, so I'll have the even numbers from 1 to 9 is 2, 4, 6, 8. So what if this is 90? So you have a long number to deal with here. So you see see the power of the algorithm, so very fast. But what if I change this thing to odd? So you notice this is not the odd 1, 2, 3. So how do I return both the even and odd? But there are two ways. You can use the square bracket or you can use the curly bracket. Now to do that, let me first of all use this other one, which is the square bracket. So I have my even, I have my odd. So how do I do this now? So in order to get the even and odd separately, we need to destructure. So this leads us to a very fine topic called destructuring. So destructuring is like you're taking a part out of a whole. So it's like being thirsty and you enter and just come back home and you have some water stuck in the fridge. So you just open the fridge, take out one water bottle and drink. So you not carry the fridge and drink, you carry what? The water bottle. So destructuring means you take something out of a whole. So we do that. So you see us using this often in React. So let even, odd, then equal to, then I'll now pass this even, odd, then I'll pass the by. So if I pass in 10 here, so because of this let now, even and odd, they are now declared. So I can put my even. So if I put even there, I'll see what? I'll see the even number. So if I want to get my odd, I can get my what? Odd. So you see. So if I know I don't want to use my even or my odd, I can omit it. Then I can only want my what? My even. But now, what if I put odd here? So what if I put odd here, then even? So you notice what will happen. So this is I'm expecting this to give me what? Even, but I put odd here. So let's see what will happen. So notice it's showing me what? Odd. Because when you use and fuse a square bracket that looks like an array, the index matters. So how you arrange it matters. So if you arrange it in as even and odd, don't come and destructure it as what? Odd and even, because that means this part here will always be what? Even. So it will always carry even and put there and not odd. So if you don't want the order of the structure to matter, so you can shift alt arrow down, duplicate that, and instead of using this array brackets which enforces the order, you do what? So if you use square brackets to return, you must use that bracket to what? The structure. So let me destructure using now the curly brackets. So now if this was meant to be even and this was meant to be odd, but now because I'm using this bracket, it does not matter. So what I pass in here will always be what? Odd, because it's here. Even will always be what? Even. So there will be no conflict like this other one. So if I save that, I will still see my what? I will still get my even, because it's my even I'm using here. I'm no longer getting the odd. So if I now put my odd, so let me activate this, I'll have what? My odd number. So this part of the video is very important because we'll use this a similar thing, especially this square bracket in our React. Very, very, very important. So that is the power of algorithm. So you see, by applying this algorithm, we are able to develop an algorithm that generates the even and odd number from a given number. So if I make this 1000, to see how efficient it is, it will having. So what is the error there? Oh, that is the function creation. So that is not meant to be a number. So if I make it out to be 1000, so you notice that my even and my odd number will be so long. So you see 500, 500. So you see this is the list of even numbers. So you see how we use something small to not be something what complex. So that is the power of algorithm. So if you have a problem and you follow this step, so you notice that by the time you get to this third part, you've known all the topics that you need. And in case you fail to capture a topic, but while you're doing it, you can still come back and replace, so that at the end of the day you know the steps and the conversion. So by the time you do it often and often, then you can get the hang of it. So using this knowledge, I expect you to write a clean code that mimics how we make transfer using our ATM. So the last thing I want to show you, I just remembered now. So I'll show you how to use prompt. So the last one is confirm. So the confirm is used to confirm something. So it's very, very easy. So let's entered age. So I will ask the user now. Prompt. Prompt. Please enter your age. Then I'll now use let's confirm age be equal to confirm so I'll use backtick. Are you sure that entered is your real age? So whatever the person answers will be saved inside a confirm. Then alert. So alert age accepted. So let's run the program. So the first one will be what? Please enter your age. So let me add 55. So if I save this now, it will ask me, say, are you sure 55 is your real age? So if I press no, cancel, it's going to show me age. So I'm going to use an if condition now to now decide the alert that will show. So if it is true, show me age accepted. So let's look at this. So if you look at this confirm, so console the log confirm confirm age now. So let's do that again. It will return true if the user press yes. So age 66. Then are you sure that is your age? So if I enter yes, I will see true, then age accepted. So that means, so I can use my ternary operator that if confirm age is true, it show me what? Age accepted. Or else alert age rejected. So this is the ternary operator. See how using that if. So if this is true, it should run this. If that is false, you run that. So 77. Are you sure is your age? Yes. So you see age accepted. Let's run it again. 22. Are you sure that is your age? I say no. So you see age rejected. So this is kind of the console output I want you to use to build your application. So that is it for this part of the class. So with this, I believe you can do your assignment now. So see you in the next class for week 6.